Hello everyone. So in this video, we are going to understand about the Newton Forward Interpolation Method. And this method works for the equal intervals. So we will see what is interpolation method and why do we need interpolations. And then we will see an example to understand this Newton Forward Interpolation Method. And in the end, we will see how we can implement this Newton Forward method using a C program. So let's start. So before understanding what is interpolation, let's understand what is the need for the interpolation. For example, we are given a function fx equal to x square minus 2x, and we have to find the value of this function at point 4. Okay, so we can easily find the value of the f of 4. We can simply put 4 in this equation and we can simply find the answer, which is 8. But the question is, if we do not know the function fx, then how we can find the value of the function at a given point? So what do I mean? So I mean, if we are given this type of table only, for example, we have some values of the x 3, 5, 7, 9, 10, and the corresponding value of the y 16, 20, 24, and so on. So this 16 is the corresponding value for this x equal to 3. For x equal to 5, we have the corresponding value as 20 for y, and so on. And now let's say we are asked that at x equal to 5.6, what will be the value of the y? So your 5.6 will be lying between these 5 and 7. So what will be the value of the y corresponding to this x equal to 5.6? And we do not know the function fx, which is actually describing this table. So here we do not know fx, that is the function. So here we will be needing the interpolation method so that we can find the corresponding value of the y for this x equal to 5.6. And when we know the function already and we are asked that please find the value of this function at a particular point, then we can simply put this value in this function. In that case, we do not need any interpolation method. So the main point is, if we do not know the function, then we can use the interpolation method to find the corresponding value of the y for the respective value of the x. So if I formally describe what is the interpolation, so as we have studied, interpolation is finding the value of the y corresponding to any value of the x between x0 to xn. So this is the table we are given, and these are the value of x, x0, x1, x2, and so on, and the corresponding value of the y from y0 to yn. And we are given any point x equal to xi, and we have to find what is the value of the y corresponding to that xi. So for example, this is the table we are given and these are the values. So let's say we can be asked that at 3.4, what will be the value of the y? Or we can be asked that what will be the value at x equal to 9.8 for the y. Similarly, we can be asked that at 7.5, what will be the value of the y? So in all these cases, to find the value of the y for the corresponding x, we will be needing the concept of the interpolation. So let's see what are the different types of interpolation formulas or the interpolation methods. So let's say we are again having the same table that we have seen earlier. And here if you see, between the various values of this x, we have equal gap. That means between 5 and 3, what is the gap? So gap is of 2. And again between 7 and 5, what is the gap? Again it is of 2. Again between 7 to 9 and 9 to 11, there is a gap of 2, right? So this is called equal interval. So all the formulas that I will be telling you for now, they will be working on the equal intervals. And what are the methods for the unequal interval? Those we will be seeing in the another videos. So what do you mean by unequal intervals? So for example, this is 3, but instead of 5, let's say we have, let's say 10. Then here we have 11, here it is 12, and let's say here it is 20. So gap between 10 and 3, it is of 7. Between 10 and 11, it is gap of 1. Here is a gap of 1. Here it is gap of 8. So here we can see there is no uniform gap between the values of x. It is 7, 1, 1, and 8. So at these points, we will not be using the methods that I will be describing you just now. Okay. So let's see the various methods for the equal intervals. So as I told you, you can be asked that what is the value of the y at x equal to 3.4. So this 3.4 is lying in the starting, right? Again, you can be asked that tell me the value of the y at x equal to 9.8. So this 9.8 is lying between 9 and 11, and 9 and 11 are lying at the end of this table, right? Now, in the similar manner, you can be asked that what is the value of y at x equal to 5.7 or 7.6. So 5.7 will be lying here and 7.6 will be lying here. So that means these x values which are asked, they are lying in between this interval, right? So on the basis of where this x is lying in this table, we can use different methods for finding the corresponding value of y. So if x is lying in the starting of this table, then we can use the Newton Forward Interpolation method to find the value of y. If this x is lying at the end of the interval, then we can use the Newton Backward Interpolation method. And if x is lying in between this interval, then we have the central difference interpolation formulas. And these are the various different formulas for this case number 3. Okay, and we have to remember all these formulas will work for the equal interval when there is an equal gap between the corresponding values of these x, right? So in this video, we are going to understand about the Newton Forward Interpolation method. And in the upcoming videos, we will be seeing that how these other formulas will work or how they can be implemented in a C program. So let's start with our Newton Forward Interpolation method. So here is our question. We are given this table and these are the values of the x, 1891, 1901 and so on, right? And these are the corresponding values of the y, that is 46, 66, 81, 93 and so on. So this 1891 is a year and this 46 is a population. So what does this question means? We are given some years and corresponding to each year we are given the population, and this population are in thousands. That means in the year 1891 we have the population as 46,000. In 1901 we have the population as 66,000 and so on. So what we have to find in this question? So question says we have to find the value of y at x equal to 1895. So where does this 1895 lie? So 1895 lie here between 1891 and 1901. So at 1895, what is the value of the y? We have to find this. So as this 1895 is lying in the starting of this interval, right? So we can use the Newton Forward Interpolation method. Now before starting this method, we should be sure about one thing. What is that thing? Whatever the answer we will be finding using this Newton Forward method, that answer will be between 46 and 66. Why? Because you can see from this pattern also that these 46, 66, 81, they are in the increasing order. So by the aptitude also we can understand that we can get answer here, for example, something like 50 or 55 or so on. So answer will be lying between the 46 and 66 for the value of the y. So here I have written the data given in the question in the vertical manner. So the question is same. This x corresponding to year and y corresponding to the population. Okay. So now let's understand how we will proceed with this Newton Forward Interpolation method. So the first step in Newton Forward method is we have to create a difference table using the given data. So how we can create the difference table? So for that, what we have to do, we have to find the various differences between the values of the y. And how we can do that? So let's see. So first we have to find the difference between the 66 and 46. And we will be writing the answer here. So if we find the difference between the 66 and then 46. So what will be the answer? So it will be 20, right? Now again, we have to find the difference between 81 and 66. So you have to remember that we are first taking this and then we are taking this. So 81 minus 66. What will be the answer? So it will be 15. And again, we have to find the difference between 93 and 81. So if we find the difference, we will get 12. Again, we have to subtract 101 and 93. So 101 minus 93, it will be 8. So in this way, we have found the various differences: 20, 15, 12 and 8. So let me write it clearly. So now all these differences that we have found, they will be termed as del of y. So this operator is called del or delta or sometimes it is also called as forward operator. Okay, so now we have to find the next difference. So next difference we will be calling it as del square y. That is the second difference. Now this second difference will be found from this del y values. And how we can find? So again we will be using the same thing, that is we will be subtracting 15 and 20. So 15 minus 20, what you will be getting? You will be getting minus 5. Now you have to subtract 12 and 15, so it will be minus 3. Now subtract 8 minus 12, it will be minus 4, right? So this is del square y. Now we have to find the third difference. Okay, so we will keep on finding the difference till we get a single value, right? So here we have got three differences, minus 5, minus 3 and minus 4. So we have not got a single value, so we will keep on continuing with this process. So we will be continuing with this process. So now we have to find the third difference. So how we can find? Again we will be using all these three values. So we will be subtracting minus 3, then minus of 5. So this will be positive 2, right? Now we will be finding the difference between these two values. So minus 4 minus of minus 3. So it will be minus 1. So let me write it clearly. Now we will continue this process one more time, because in the fourth difference we will be getting a single value. So if we subtract minus 1 and then this 2, so we will be getting minus 3 as the final value. Okay, so now as we have got a single value, so we will stop our method. Okay, so this is the difference table that we have got. Now before proceeding further, let me clarify one thing. Some people may write the difference between the various values as like 66 minus 46, what we have got 20. So one can write in between here 20, and again this difference between 81 and 66, it is 15. So one can write 15 here in between these 66 and 81. So that process will also be correct, because that is just a different way of writing the answers. Okay, so we will be using this method that I have described. Why? Because it will be easy for us to understand when we will implement this method in our C programming. Now after finding the difference table, we have to apply the formula so that we can find the value of the y for the value of the given x. And this is the formula for Newton Forward Interpolation Method. The formula says the value of the function at point a plus hu. It will be f of a plus u of into del of f of a plus this term and so on. So this series, you can say, it will be containing many terms according to the question given. Now what is the meaning of various terms? So let's understand. So here this a is the starting value or the initial value of this x table. Okay, so the first value of this x is 1891. So this a is also called as base term, you can say. Now what is this h and u? Now before this we should know that this y can be written as del of f of x. Okay, the same way this can be written as del square f of x. That means at the corresponding x we are finding the second difference, first difference and so on. Okay, now in this question we have to find the value of y at x equal to 1895. That means we have to find f of 1895, right? So this a plus hu can be equal to 1895. You know a, what is this a? A is 1891, the initial value 1891 plus hu. Now what is this h and u? So this h is the gap between the various term of these x. So between 1901 and 1891, what is the gap? So the gap is of 10. The same way the gap between these two terms will be 10. Again difference between 1921 and 1911, it will be 10. Okay, and so on, it will also be difference as 10. So this 10 or the gap which is actually equal between various terms of x, this is h. So we can say our h is 10. Okay, so we are given h also now, so we can easily find the value of u. So by putting all these values we got u equal to 0.4. So for this formula now we know that this a plus hu is actually 1895 and we have found the value of u also. Okay, and what is this f of a? So you can simply say this f of a is actually f of a is 1891. So that means this value 46. Now you know u. Okay, what is this del of f of a? So this is del of f of 1891, right? So this is actually del of f of 1891, that is 20. So we can find this term u into f of a, right? So now we can find the value of this, that is u multiplied del of f of a. Now in the similar manner we can find this value also. So we know the value of u, okay, and 2 factorial is, you know that it is 2. Now what is this del square f of a? So del square means this column, right? Now what is this f of a? F of a means f of 1891, this one, because this is a. So this f of 1891, for the second difference it will be this term minus 5, right? And in the similar manner, when we will be finding this value, so here del cube f of a, it will be this one. Now in this question we have to find the next value also. Next value will be like del 4 of f of a. So that will be this value. In this way, we can put the various values of the various symbols which are written here, and we can find this f of 1895. That is the corresponding value at x equal to 1895 for y. So let's see how we can do that. So here I have written the various values of a, u, h that we have just understood, and this is the formula that we have also seen. So we have to find the value of the f of 1895, right? So you know what is the value of f of 1891. So you can see here, we can write this y as f of x, right? So at 1891, what is the value of this y? It is 46, right? So we will write 46 plus what is the value of u? It is 0.4 multiply. Now del f of 1891. So as I told you, this is del of f of 1891. Okay, so this is 20. Now again I put the value of u as here and into del square f of a, that is the second difference. So del square f of a is minus 5. So we can just understand one pattern, that for the Newton forward interpolation method we have to take these values, that is 20 minus 5, then we will take 2, and then at last we will take minus 3. Okay, so for the now we will take minus 5. Now for here del cube f of a, what will be the value? So it will be this 2. So we will put all the values. So here we can see it is minus 3 for del 4 of y, right? Now I hope now you can easily solve this formula. So this 2 factorial will be your 2, 3 factorial will be 6, and 4 factorial will be 24. And when you will solve this whole complete formula, then you will get the value of the function at f of 1895 as 54.8528. Okay, so this will be your f of 1895. So that means your population for the year 1895 will be 54.8528 thousand. And if you see, this 54.8 is actually lying between this 46 and 66. So I hope you have understood this method. So just for the recap, what we have done, we have first created the difference table. How we have created? We have find the various differences, and differences you have to take care that you have to find the difference between this 66 and then 46. That is 66 minus 46. You are getting 20. Do not do this like 46 minus 66. Then it will be a negative value and you will be getting the wrong answer. Okay, then you find the difference between 81, 66 and this and this. Okay, and after that you again find the difference between these 15 minus 20, 12 minus 15, 8 minus 12, and so on. So this process we will be continuing till we get a single value. And after getting this difference table, we will be applying the formula and we will be using all these values in our formula. So we will be using only this 20 minus 5 2 minus 3 values in our formula. Okay, and this a is the base term, that is the first initial value of the x, and this h is the equal interval. Okay, the equal interval is actually 10, and we can get this value u as a plus hu equal to whatever the value of the x that we have to find in the question. And then we can put all these values in our formula and we can simply find our given answer. So we have understood how this Newton forward interpolation method can work on the given question. So now it's time to understand the pseudocode for this question so that we can implement this method into our C program. So here is our algorithm for this method. So first we have to ask the user that how many terms you want to enter, and we will be saving those number of terms in this variable n. So what does it mean? So here you can see in this given question we are having 1, 2, 3, 4, 5 terms. Okay, 5 values of the x and corresponding 5 values of the y. So that means we are having total 5 terms, right? So this is the value of the n. Okay, and now what will be the next thing that we will be asking? So next thing will be the various values of the x and the various values of the y. So how we can save the various values of the x and y? So actually to store the values of the x and the y, we can take two different one-dimensional arrays. The one of the array will be storing the value of the x and one of the array can store the value of the y's, right? And the another method is we can take a big 2D array in which the first column or the 0th column will be storing all the values of the x and the first column will be storing the values of the y's. Okay, so you can see this as the matrix. So you can say these are the rows 0, 1, 2, 3, 4, and these are the various columns 0, 1, 2, 3, 4, and so on, right? Now depending on the question, we can say what will be the size of our matrix. So as we have seen in this given question that when we have n equal to 5, that means we have the 5 values of the x, 5 values of the y, then how many different columns we need? So here you can see we got 4 differences, then 3 differences, then 2, and then at last 1 difference. Okay, so we need 4 more columns to store the differences, and these are the 2 other columns. So total 6 columns we need, right? And how many rows we need? We need 5 rows. So that means for n equal to 5, rows will be, you can say 5, and columns will be 6 as we have seen. Okay, now in the same way, if n is equal to, let's say, you can say 4. Okay, so if n equal to 4, then our matrix will be somewhat smaller. So for n equal to 4, you can see that we will be needing rows equal to, you can say 4, but columns will be 5. So that means column will be one more than the number of rows, or you can say one more than the value of the n. So that's why we can take the size of the matrix as n plus 1. N is the number of rows and n plus 1 is the number of columns. Okay, now after asking these x and y's, what will be our next thing? We will be asking the user, tell me what is the value of the x for which you want to find the value of the y. So in our given question, we said at x equal to 1895, tell me the value of the y. Okay, so this is this x. Now after that, what we have done, we have created the difference table. After that, we have find the value of the u, and we have applied our formula to find the corresponding value of the y for the given x. So let's see how we will be writing the pseudocode for all these steps. So here you can see to enter the values of the x, we can use a simple loop. Okay, so this is the 0th column and the rows will be 0, 1, 2, 3, 4. So this is 0, 0, this index is 0, 1, and so on. So only the rows are changing. So this is the row and this is the column. So I will be ranging from 0 to, you can say, 4 for n equal to 5. So we will be filling all the values of the x. In the similar manner, we will be entering the value of y in the next column. So our column will be 1. Okay, so the same type of loop we can use here to enter the value of y. So now we have got our this table, the value of the x and the value of y. Now the third thing is we have to create this difference table or the we have to find the various differences. Okay, so here is the pseudocode for creating the difference table. So here we have used the two loops. Okay, and here we are finding the aij. So this aij is actually these values, okay, at the various places. Okay, and this is the difference that we are finding. So here you can see we have the minus operator. We are subtracting the two values. So let's see how we can do that. So what we are doing, we are actually first filling the second column, right? And when we are done with the second column, we are coming to the third column, and then fourth column, and then fifth column, right? So at last we went to our fifth column also. Okay, so here you can see this is actually corresponding to your column. Okay, so j is starting from where? J is starting from 2. So this j is starting from 2 and it is going till 5. So here I have written as j less than n plus 1. So n plus 1 will be 5 plus 1, 6. So it will be running for 2, 3, 4 and 5. So j less than 6. So the last jth value will be 5, for which this loop will be satisfied. So you can write this as j less than equal to n also. That will also be correct. Now this inner loop, it is actually corresponding to the various rows. So this I, you can see that it is always starting for 0. Okay, so for various values of the j, it is again and again starting from 0, right? Now here you can see when we are in the second column, how many times we are finding the differences. So we have found the differences 4 times. 1, 2, 3, 4. Okay, that means we have subtracted 4 times. First this one, then this, then this, and then this. Okay, 4 time differences. When we have filled this second column, we came to the third column, and now here how many times we are finding the differences. So here you can see only three differences we have found by subtracting this, this and this. Okay, so in the fourth column we are finding the 2 differences only, and here only 1 difference. That means the number of differences in each of the column, they are getting decremented by 1. Okay, as the column increases, your number of differences that you are finding, they are getting decremented. That means this ith loop will not always run for the equal time in each of the column, or you can say for each of the jth value, this I loop will not always run for the equal amount of time. So this I less than will not be a constant thing. It will be depending on which column we are present. Okay, so on the jth value, this test condition will be dependent. So you can see here I have used n minus j plus 1. That is, I have used this j as the dependent thing here. Okay, let's say we have j equal to 2, that is column equal to 2, and now this j equal to 2 is less than 6. Okay, so we started from I equal to 0. Okay, now how many times this loop will run? This should run for the 4 times. For the j equal to 2, this should run 4 times. So here you can see this will be 5 minus j is 2 plus 1. So 5 minus 2, 4. So 5 minus 2 is 3. 3 plus 1, 4. So this loop will run for 0, 1, 2 and 3. Okay, so that means 4 times. So for the I equal to 0, here you can see this will be a of I is 0 and j is 2. And here this index is 0, 2, right? So you can see this will be 0, 2. Let's say we found somehow the difference, okay, that we will see later. In the next iteration, this I will be equal to 1, right? For that, this will be 1, but column will remain same, A12. Again, I will be 2 in the next iteration. So this will be I is 2, but column remain same. So this is 0, 2, 1, 2, 2, 2. So this is 0, 2, this place is 1, 2, and this index is 2, 3, and so on. So that means this loop is running okay. So for I equal to 0, let's find the difference. So here we have to find the difference between 66 and 46. So here you can see we have this j equal to 2, I equal to 0. And we have to find the difference between 66, 46. So what is this index? So this is one row and this column is 1. Okay, and this previous was also 1. Okay, now this 46 is present at the 0 comma 1 index. Okay, so we want to find the difference between index 1 1 and 0 1. Now here you can see this I is initially 0, but what we want the index 1, so I wrote I plus 1. Okay, now j is 2. Okay, j is 2, but what is the value of the j we want 1, so I subtracted 1. Okay, now so this is 1 and this is 1. Now minus, we want 0 1. Okay, I should be 0 now. So here if we directly write I, that will work. Okay, 0. And what is this j minus 1? So j is 2. We need 2 minus 1 because we are again in the same column. So as we did j minus 1 here, we have to do j minus 1. So 2 minus 1, 1. So this index 1 1 minus 0 1 index, 1 1 minus 0 1 index. That means 66 minus this will be 46. So this will be your A02. That means 20, right? And in the next iteration, when I is 1, so here what we will be getting? So this will be your 1 plus 1, 2. Okay, this is A2, but j will remain same because for this loop j is not changing. So this j will be 2 only, and here j is, so that means index 2 2 minus index 1 1. So this is 2 2 index and this is 1 1 index. 81 minus 66, we will be getting 15, and this will be getting stored inside this A12 and so on. So this way we have got this difference for the column j equal to 2. Okay, now in the next iteration, this outer loop will be again running for j equal to 3, and again this I loop will run for I equal to 0. But now you can see here, because j has incremented and j will become 3 now, so this n minus j plus 1 will not be 4, it will be lesser than 4. Okay, so that means n is 5, j is 3, and this is 1. So 5 minus 3 is 2, 2 plus 1, 3. So that means this I will be less than 3. So that means I will run for 0, 1 and 2. That means 3 times. And we see that for j equal to 3, that is third column, we are finding only the 3 differences. So that means we are going into the correct direction. So now you can see here, for finding the difference for the column j equal to 3, we have to use the j equal to 2th column, right? But we are currently at j equal to 3 and we need the previous column, right? So here you can see we are using j minus 1 for the column values because we need one lesser column number. Okay, and the row number, they are again starting from 0 1 and so on, right? So here you can see when we are finding this minus 5, we are again saying that we are currently at I equal to 0, but we want to catch this 15. This is at the position or the row number 1. So that means I need to increment I. So that's why I use I plus 1. But this 20 is at the same row in which we are having currently. That means currently I is 0. So we need I equal to 0. So that's why here I have not added or subtracted with I anything. Okay, so here it is I plus 1, it is I, and j is always j minus 1, right? So in this way, again for I equal to 0, we will be finding what value? This will be a, this is 0, and j is currently 3. So this we will be getting A03. Okay, and in the similar manner, we will be subtracting this 12 and 15 for I equal to 1, and so on for I equal to 2. We will be finding this minus 4 after subtracting this 8 minus 12. Okay, so in the similar manner, for j equal to 4, we will be finding difference, and for j equal to 5, we will be finding the differences. And we have to take care, or we have to understand that this I will be lesser than such value, which will be saying that this loop of I will always be decremented. That means for the first time, it is running 4 times, then 3, then 2, and then 1. So do not just write I equal to 0, I less than n. Otherwise, it will be wrong. Now again one can ask, if I just write I less than n, what will be the wrong thing? Actually it will not be a wrong thing. What you will be doing, you will be just wasting your time in finding those values which are of actually no use for you. That means if you run the ith loop for total number of rows, for let's say 0 1 2 3 4, for j equal to 2 also you are running for this 0 1 2 3 4, that is 5 times. Again for next column you are running this I loop for I less than n for all the rows. So you will be filling all these spaces also. Okay, and you know that in the formula of this Newton forward we are not using these values. Okay, so you will be just wasting the time for finding those things which are of no use. Okay, so that's why to save our time we are not writing I less than n. Now you have created the difference table. So what is the next thing? We have to apply the formula. So this is our formula that we have to solve. So here there are many terms that we have to first find to solve this formula. So here you can say we have the u also, right? So this is the formula in our code which we have used to find the value of u. So you know that how we can find this u. So this a plus hu is equal to actually 1895, and this 1895 was the value of x at which we want the value of y, right? So we can say a plus hu is equal to 1895, right? Or you can say this is x. So by this we can say u will be equal to x minus a upon h. So this formula we have used at this place. So this x is the same x, that is 1895, and then we have the a. So we know this 1891, that is the base term. This is a. So this is present at 00 index. So this is a00. Now divided by this total is actually h, that is the interval gap. So this h is actually the subtraction of these two values, 1901 minus 1891. So this will be your 10. So this 1901 is at 10 position. 1891 is at 00 position. So these things we have written here, a10 minus a00, right? So in this way we have found the value of u, which was coming as 0.4 for a given example, that is for x equal to 1895. Now to solve this formula we have to see some of the observation. So here we can see we are again and again adding the various terms. So this is one term, then u multiply del of f of a, this is second term, then this is the next term, and this is the next term, and so on. So this series is actually the sum of many terms. Okay, so what you have to do, you have to find this answer, then you have to find this answer, this should be added with this, again you have to find this term, and this should be added with the previous answers, and again you will find this term and you will add with the previous answer, right? So in our code this y is actually finding the total sum of these various terms. Okay, so final answer of this total sum will be inside this y. Okay, now in this formula we can say here we have the factorial terms also, right? So this fact is storing the various factorial. Okay, and here we have the two terms like u1 and the u. So you already know that this is the u. Now what is this u1? So we will see while we will solve this question. Now we have to take the some initial values of this y fact and the u1. So we are doing y equal to y plus. So what will be the initial value of the y? Okay, so here you can see in the formula this will be treated as the initial y value. Okay, so here you can see y equal to a01. Now you know what is f of a. So here a means the base term, that is 1891, right? So f of 1891 is 46. So this 46 is present at 0, 1 position. So this y equal to a01, that is 46. So this we have stored inside the y. Now for the time being we have said u1 equal to u. Okay, so u is 0.4. Now factorial, this is equal to 1. So initially it is 1. Now we run this loop. Okay, so we are running this loop from I equal to 2 to I less than n. So you can see that we have to use these values 20, -5, 2 and -3. So we are starting from the first value, that is 20, okay, because 46 has already been used here. So we start the loop from this column, that is second column, right? So this I, you can say this is resembling the column, okay? So let's start. So the first line is saying y equal to y plus the sum of the answer that we will find from here. So this is your 46, or you can say this is your initial y. So this is like 46 plus, now this total is actually this answer, that is u multiply del f of a. So here you can see we have saved the initial value of u inside the u1, okay? So we can safely use u1 here, that is 0.4. Now multiply, we need del f of a, that is delta value at f of 1891, right? And this is 20, so this will be your 20. So multiply 20. Now you multiply this a0i is this, okay? And I was initially this 2, so a02 is 20, okay? So that we have put the correct value. Now upon we can write 1 factorial or 1, okay? So it will not make any difference. So here we have divided by factorial. So fact variable is storing the initial value as 1, so divided by 1, okay? So this will give me the sum of these two terms, right? And now this is getting stored inside y, okay? Now we are currently at I equal to 2th iteration, okay? Now before going to this term, or we can say before going to the I equal to 3rd iteration, we will pre-compute the factorial value, that is this value, and we will pre-compute this u1 value. And what is this u1? So actually when we will come to this I equal to 3rd iteration, that is when we will come to I equal to 3, and when we will be computing y equal to y plus this thing, then you can see here this thing u multiply u minus 1, this will be treated as u1, okay? And then multiply a0i, that is this thing will be a0i, and divided by factorial will be this thing. So currently we are at I equal to 2th iteration, and we are computing u1, that means this term, okay? So how we can compute this u multiply u minus 1 while we are at I equal to 2th iteration? So here you can see this u1 is actually the current value of u1 is 0.4, right? So you can say this is 0.4. Now multiply u minus, here you can see this is u, okay? So u is again 0.4 minus, now I minus 1, so I is 2, okay? And 2 minus 1 is 1, okay? So here you can see we need 1 also, okay? So if I write here only I, then it will be 2, but here we need 1, so I have to subtract minus 1 from this I. So now this is my u1, okay? So after computing this fact, which is actually now 2, and this u1 is actually this one, we will go to the 3rd iteration, and you can see here fact will be 2. How? Because fact initially the currently was fact was 1 and I was 2, so 2 multiply was 2, okay? So now we have computed all the values of fact and u1. Now we come to the next iteration, that is I equal to 3. That means we are now I equal to 3. So here we will put all the values. So here we are saying the old value of y, okay? Old value of y is the sum of both these terms, okay? Then plus u1 multiply some term. So this u1 we have already computed, okay? So that value will be placed here. Now multiply a0, now I is 3, so a03 will be your this minus 5, okay? So this is actually a03, this value delta square f of a, okay? Now divided by this 2 factorial, so fact previously was 2, so this will be divided by 2. So that means we have computed this term and we have added this answer with this previous y. This whole answer is stored inside y, and we are currently at I equal to 3. So again we will compute this answer as u1 while we are at I equal to third iteration only. And we will also compute this 3 factorial, that is 6. Let's see how. So currently your fact variable is having this value, that is 2. And if I multiply it with 3, that is I, then I will get 6. So my 3 factorial is saved inside this fact variable. Okay. Now we have to compute this u1. Okay. So for u1, you can see this total answer u multiply u minus 1 is already pre-computed. Why? Because this is same thing we have used here. Okay. And this thing is already saved inside u1. So we have said u1 equal to the previous u1 or the current u1. So current u1 is this u multiply u minus 1. Okay. So we are not computing it again. Okay. We are using the old value. So this part, you can say this part. Okay. This part is already the u1. Okay. Multiply. Now we need this answer u minus 2. So u is the this previous, or you can say initial value 0.4. So this is not u1, this is u. Okay, u. Now minus, you can see here I am currently at I equal to 3, but I need minus 2. So I have to subtract minus 1 from this I. Okay, so now u1 multiply u of minus I minus 1 will give me this term, okay, and this total answer will be saved inside this u1. Okay, so in this way I have computed u1 in fact, and now I will go to next iteration I equal to 4. So now I will come to this place, and again at I equal to 4 I will say the previous y plus this u1 multiply this answer u1 multiply this a0i means a04, a04 is this 2. Okay, then divided by this factorial, that is 6. Okay, so I have computed the whole answer as y. Okay, so all these 4 terms will be stored inside y, and again I will compute this fact and u1 for the next term. Okay, this will be plus, and the next term, so next term will be like having delta of 4 f of a. Okay, which will use this answer. So in the same way the next iteration will go on, and I will repeat the same process for the next iteration, and finally my answer will be saved inside this y variable. After this for loop I will just print here y. So I hope you have understood that how we can apply this formula and find the various values of this formula, and how we can add those values, and how we have pre-computed the next values in the current iteration only. That is how we have computed this fact and u1 from the previous fact and the previous u1. Okay, so this was the simple mathematics or the simple implementation of the mathematics in a C program. So there was no big rocket science in this. Okay, so let's move to our C program and see how we can implement this pseudocode into our C program. So here is our C program. So here I have written the main function. So inside main function I have taken a matrix, and the name of the matrix is A, and the various variables I have taken here. So first we have asked the number of terms from the user, and this is saved in n. Then inside our loop we have asked the value of x and the values of the y. Then we have asked the user that at which value of the x you want the value of y. So we have saved that into a variable x, and after that we have find the difference table. So this is the same code that we have just discussed. Now after finding the difference table, we have printed the difference table. So I have printed because it is like easier for us to find the error if in case the difference table is not correct. Okay, so by looking the difference table we can see, okay, where is the error we are getting. Okay, now after printing this difference table we have find the value of the u. Okay, and after that we have taken the initial values of these variables, and then we have applied the for loop to calculate the various values of the formula and applied the formula. Okay, and after that we have printed the final value of the y for the corresponding value of the x. Okay, so let's run this program and see what is the output. I entered 5 as the number of terms, and then value of the x, we will be entering the same values that we have just discussed. Now we have to enter the value of y as 46 and so on. Now I want the value of the y at 1895. This is the value of the x. So you can see my answer is 54.852798. So this is the similar answer that we have got when we worked out our example, and you can see this is the difference table. So we have got the correct answer. So if I run this program at some another values of the x, for example at 1925, so it will be at the end. Although I have told you that Newton backward interpolation method works fine when we want to find the value at the end, but this forward method can also be used. So let's say if I run this program again, so this is 5, and now at 1925 I want the value. So here you are seeing it is 96.83. okay, so that means it is between 93 and 101. okay, so this answer, if you try using the Newton backward interpolation method, you will get the similar answer as 96.83 at 1925. So it does not mean that only the Newton backward method can work when we are finding the value at the last point. Forward method can also work, but at some places backward method will only work, or it will be giving us the correct answers for if we are getting or if we are finding the values at the last point. okay, so just make it a habit that forward method you will be using at the initial values of the x. For the last values of the x, you will be using the backward method. So I hope it is now clear that how we can implement this method using a C program. And please watch my other videos on the numerical methods like regular fallacy, bisection, Gauss elimination, and other methods. You can find the link of that playlist in the video description. So if you have any comment, please write down into the comment box related to this question or any other question. Do like and share this video, and please subscribe this channel and press the bell icon for further notification. See you in the next video. Till then, goodbye.